So this week we're going to start our fourth unit for physics. It's called electricity and magnetism. And for the first week, we're going to be focusing mainly on the things you learn in grade 9 from the electricity unit there. That probably took you a month or 5 or 6 weeks or so in grade 9, but we're going to squish all of that down into a few days. So these first few lessons are going to go by pretty fast. We're going to review all of that stuff from grade 9 pretty quickly, starting in this video with circuit components, connections, and circuit diagrams. So first of all, I'm going to talk about the simplest circuit we can possibly have. It requires at least 3 things. It needs a power source, which is something to provide the energy to the circuit. It needs a load, which is something that uses the energy that's provided by the power source. And then it needs conductors, which are materials, usually metals, that will connect the power source to the loads and back to the power source, something that electrons can pass through. So I'm going to try to show you by breaking down this flashlight here. Okay, this flashlight basically has these 3 components in them. But I'm gonna try to unscrew it to show you the parts. Okay, so inside the flashlight I've got a couple of batteries. So that's going to be the power source. And inside the top of the flashlight, I took it apart, you can find a light bulb. So that's going to be the load. So we got the power source and we got the load. And then we need something to connect these together, some kind of a conductor. So in the flashlight, the conductor it's built within this case that you hold the flashlight with, so it's nice and sturdy and all of that. But what I'm going to use as my conductor is a piece of aluminum foil, which I've kind of rolled up to try to make like a wire. So what happens in a flashlight, there's 2 batteries and normally they're stacked together. I'm just going to use one battery, and batteries have 2 terminals. Okay, there's the negative end and then there's the positive end. So in the circuits that we're going to do in class, we're going to start the circuit at one end of the terminal. So I connect the conductor to one end, which I'm going to lay flat down on the table here. And then we attach it to the load. So this light bulb also has 2 terminals. It has the very bottom, there's a nodule, which is a terminal. And then around the outside here is some metal, which is like the other terminal. So I'm going to put one terminal to the other terminal of the battery. And then I'm going to try to connect my conductor to the light bulb. Alright, so now you may see the light bulb glows when I have it connected. And that's the simplest circuit. Okay, so it starts at one end of the battery, goes through the conductor, through the load, and back to the other end of the battery. Alright, so that's the simplest circuit. Some circuits, one step further would be to add another component called a switch. Most circuits in like the house have a switch, something to turn it off and on. A flashlight has a switch as well to turn it off and on. It's not necessary for a circuit. You can still make a circuit work without a switch, but usually circuits have switches, so you can easily turn them on and off. Alright, and there's just a picture of the circuit for the slideshow. What happens if there is no load? Okay, so you have a power source, you have conductors, but what happens if you don't put a light bulb to it? So now I'm going to show you this. This is called the Virtual Circuit Construction Kit. It's a website made by the University of Colorado. I've actually showed other simulations for other units through here, but you're actually going to be using this one probably pretty often for this unit to build circuits. So you can drag a battery out from the side there. You can drag some wires out. You can stretch the wires and change the direction of wires to whatever you want. So I'm just gonna connect one wire to one end of the battery, make this kind of a rectangle. And you can grab a light bulb out, and then I can connect this light bulb with another wire back to the other end of the battery. So this is just the circuit that I made with the flashlight I just showed you. But what happens if there is no light bulb and you try to connect it? So I've got these two ends of the wire. Right now they're not connected. But now if I connect it, you'll see that things are going really quickly. So what happens without a load is that, well, where's the energy going to go? Okay, the energy that's supposed to go to the light bulb and make a light is now being used to make thermal energy and lots of heat. And that can be pretty dangerous. Things can catch on fire. So that's what happens if you don't have a load. We call it a short circuit. If you don't have a conductor, then obviously you can't connect the things together. And if you don't have the power source, well, then you have no energy. So that's why the minimum requirements for a circuit are a power source, a load, and a conductor. So then what you did in grade 9, before that, there's also series and parallel connections. So you can have multiple batteries, you can have multiple light bulbs, and then you can connect them in all these different ways. But really there's only two main ways that things can get connected, either in series or in parallel. In series means that they're in the same pathway. So here's a diagram of a circuit in series. I've got 3 light bulbs and I've got 2 batteries or 2 cells, and they're all in one pathway. Okay, they're all connected in one giant rectangle basically. So we call that a series circuit. The other method is called parallel, and that's when you connect the components in different pathways. And if there's different pathways, then there may be like a fork in the road. If you go hiking on a path and then you have a choice of 2 paths, it's like a fork in the road. And those fork in the roads for circuits, we call them junctions. We don't call them forks, we call them junctions. So here's a diagram of a parallel circuit. So now if we start at the battery and we go around, the charges get to this point and then they have a choice. They can either keep going to the right here, or they can go down this pathway. And whichever pathway they choose, there's a different light bulb for that pathway. Okay, so when it's 2 different pathways, we call these 2 light bulbs are in parallel to each other. And this point right here is called a junction point. The pathways eventually have to meet back together, and they do so right here. So that's another junction point. And then whichever pathway the charges took, it eventually goes back to the battery. Okay, so if you're one of these blue charges, you can either start at the battery, go around and down the first path and back to the battery. That's one pathway you can take. Or you can start at one terminal, go around all the way to the outside pathway, and then return to the battery. That's your second option if you're one of these blue charges in this circuit. That's a parallel circuit. And then you can have parts that are parallel and parts that are series. So in the left diagram, you have 2 batteries that are in series, 2 batteries or 2 cells in series, but 2 light bulbs that are in parallel. The light bulbs are on their own separate pathways. Whereas the diagram on the right shows 2 batteries in parallel. Okay, the 2 batteries are on separate pathways. However, 3 light bulbs are in series. These 3 light bulbs are all on the same path. There's no split, there's no fork in the road between these 3 light bulbs. So 3 light bulbs in series with 2 light bulbs in parallel. Here's 2 more examples. I'm going to call these mixed circuits, where you have multiple loads. Some of the loads are in series and some of the loads are in parallel. So the circuit on the left has two batteries that are in series. Now it's got three light bulbs, A, B, and C. B and C are in parallel. They're separate pathways compared to each other. However, A is in series with both of them. So if I'm a charge and I start at one end of the battery, I have to go through A no matter what. Okay, I have to go through A no matter what. Then I can either come down B's path and return to the battery. So that's one pathway going through A and B. Or I can start here, go through A, go all the way to C, and then come back to the battery. So that's my second option, going through A and C. No matter which pathway I take, I have to go through bulb A. That's why we say that B is in series with A, C is also in series with A, because no matter what, you're always going through A. Okay, but B and C are parallel to each other. You can avoid, like B will avoid C and vice versa. In the diagram on the right, you have one cell or one battery, and you basically have two options. You can go down path A and just go through light bulb A, or you can go down the far path and then you go through bulbs B and C. So in this circuit, we say that B and C are in series with each other because they're in the same path with each other. But they're both parallel to A. Okay, B and C are in series with each other, but they are parallel to A because they're in a separate path compared to light bulb A. So that's series versus parallel, which was talked about in grade 9 as well. We'll expand on that more later in this unit for grade 11. Finally, our main goal for this lesson is to be able to draw these circuit diagrams. So on the left is a picture of the actual circuit I built using the components from the flashlight. But when we communicate with other scientists around the world, we don't take pictures of our circuits, we draw what we call circuit diagrams. So each component of a circuit has its own symbol, and we use those symbols to draw the whole circuit out. It's called a circuit diagram. So the next series of slides is going to remind you of the various symbols. This is a symbol for one cell. So one of these guys is one cell, and it's a long line and it's a short line. Okay, the longer line represents the positive terminal of the cell, and the shorter line represents a negative terminal. So when the cell is right side up, like it is in the diagram, this is the symbol that matches it. And I can put two cells together, and that would be called a two-cell battery. So just like this. And I have it positioned sideways this time. So if it's positioned sideways like this, then my lines need to be drawn this way. Okay, positive, negative, positive, negative. I could put three of them together. So I got negative, positive, negative, positive, negative, positive. So short line, long line, short line, long line, short line, long line, etc. I can put 4, 5, 6 of them together. So those are cells. You have a variable power supply. So these batteries they supply a fixed amount of voltage, 1.5 volts. However, if you have this machine, and we have these at school, you just can't use them this year because we're at home, but these have a knob that you can turn, and you can actually choose the voltage. You can choose the voltage. So that's why we call it a variable power, because you can vary the amount of volts you have. And the symbol for that is the same as a cell with an arrow, a diagonal arrow through it. And that diagonal arrow represents that you can adjust the amount. So I'm gonna have to finish this lesson off in a second video because I'm reaching the maximum time here. So we'll move on to the next video.